One could say there's a little more than meets the eye to this week's stories because they are all about transformation. A kernel under every Linux box becoming a root access path, the platform under every developer push becoming backend execution, the package registry under every build becoming credential theft, and the vendor installer under every endpoint becoming malware delivery. And then, of course, there's the Canva outage that really puts a spotlight on how much some platforms have transformed from software into something more resembling infrastructure, which is why our final segment this week is going to be on CISA reportedly weighing whether agencies should patch known exploited vulnerabilities in as little as 3 days. I'm Sean McMillan, Community Manager here at Bishop Fox, and I'm joined this week by Sergio Villegas, Senior Analyst 2, Dylan Sparks, Senior Operator 1, and John Untz, Senior Security Engineer and Exploit Developer. Welcome to the program.
No, thank you for having us again.
So it's been a busy week. Let's just dive right in with this first Linux copy fail bit here. This is from Wired. Basically, a newly disclosed Linux kernel flaw dubbed copy fail and tracked as CVE 2026-31431 lets a local user gain root with a 732-byte, 10-line Python script that works unmodified across virtually every major distribution shipped since 2017. We're talking Ubuntu, Debian, Red Hat, Amazon Linux, all of them. The bug lives in the kernel's cryptographic template, and unlike Dirty Cow or Dirty Pipe, does not require winning erase condition, which makes it both highly reliable and broadly weaponizable. CISA has added it to the KEV catalog. Most distros have shipped patches already, and Red Hat reversed an initial decision to defer the fix. So from an offensive perspective, for offensive operators, what does it mean when privilege escalation like this is this small, reliable, and universal, really?
I guess I will start things, if you don't mind.
Yeah.
I guess it's a great opportunity, right? Something that is really interesting for me is that, look, privilege escalation tends to be not attended that quickly by organizations, right? And that is why it's so popular. Also, something to have in mind is what it targets. It targets a plethora of different distributions, right? So it's the universality of the attack is really good from an offensive perspective. Of course, you have different flavors of firms, right? Like we at Bishop Fox, we tend to do things normally, more externally, right? But that doesn't mean that the opportunity to do something locally or even some post-exploitation techniques are in there. So that is the fun part of that, right? Like how universal this can, how this being so universal can give you access to different other tools and to different other value to give to your customer. Like, hey, I access this specific service. Would it then give me access to all of this infrastructure inside your network, right? And I think that's where you can use it a lot. I think that's where I start.
Yeah, I think it opens up a lot of doors, right? From from attacker's perspective, I no longer have to worry about whether or not something is going to give me root access, because as long as I can get access, as long as I can get past that initial hurdle of initial access, the rest of the game is already solved for me, so long as these systems remain unpatched. I think you kind of alluded to it before with some, right? Like some of these initial access vectors and exploits that we may not have considered critical before now suddenly have to be looked at with a critical lens when privilege escalation vectors like this exist. Because now something that may have been, a 7.3 before, when paired with something like this, that initial access vector is 7.3, but when you chain things together, I think that's where some of this kind of gets lost in the noise, is just because one CVE may be, not meet that critical threshold to garner a bunch of attention. As soon as you start chaining some of these exploits together, it paints a more complete picture and a more devastating picture to organizations.
Yeah, I think it's significant to, due to two things. One, the popularity of Linux servers deployed across the globe, most cloud deployments, internet-facing applications. And even now, like a lot of AI infrastructure actually runs on Linux. Again, because it's modular, it's highly dependable. So in that, what you're also getting kind of from that herd immunity, you're also getting herd vulnerability, right? So if everything's using the same process. We saw it last week with the authentication chain. If every distribution of a version is using the same authentication chain and that authentication chain breaks, well, now everything's vulnerable. So you kind of get this like really powerful hitting post-exploitation privilege escalation. But to John's point too, it also turns a lot of like formerly ignored low privilege attacks into potential, now someone could have root privileges from an unprivileged user before. So you have to start looking internally at heuristics and redirects and things like that.
Yeah. How do attackers typically find these kind of unpatched hosts?
I think that's interesting, right? Because we are taking how you can weaponize this. And normally, right, looking at the other side of the spectrum, like if you have a local user, even without it being root, you already have a problem, right? That's kind of for starters. But when you look at the weaponization and how the attackers can get that first local user, it's like, well, it's not that hard. When you go and look at different sources talking about the markets for where actors are active, it's like they are just buying access, right? Something as simple as, I know we recently had a cPanel WHM vulnerability, right? And when you look at cPanel WHM, it's a very popular thing where attackers are like, hey, I will be buying all of the credentials for cPanels across shared hostings, right? So where do you get that first local user? You already have it. You have a normal user, you have a shared hosting, you create your account, you already have access to the system. Then you just run the script, right? It could be as easy as that, as attackers just getting access to normal services that you can buy. I can create a GoDaddy account right now and have a shared cPanel account in my Linux. And then I have my weapon, right? What will I attack? Well, it depends. Where am I located right now? And you just multiply that by the vast amount of things or platforms you can create those accounts, and you compromise a lot of servers, and all of that will be shared. And this type of vulnerabilities, I think that's where they shine a lot, right? Like how you can massify those attacks and get access to a lot of information really quick, really fast. I think that's kind of where we will see a lot of this.
Yeah, I think we've kind of talked like in episodes past about like systems that have to remain untouched or remain in high uptime. You know, critical infrastructure is the first thing I kind of think of is those kinds of machines that taking a machine down to apply even a simple fix like this error mitigation requires like a change review board that inherently creates friction and slowness in a response time. I think that's where you're going to see some of these, like, you know, months down the line still see vulnerable systems is places like that, you know, hospitals. That's kind of where I look at a lot, is I look at a lot of hospitals and education and you know, places like that don't really have the security first mindset where they probably should, but for one reason or another, it isn't in that priority schema for them.
Yeah, I'm looking at, again, to call back to episodes past as well. We talk a lot about shadow IT in here.
Mm-hmm.
Sure.
And we talk about temp dev boxes or SaaS or PaaS legacy deployments, stuff that just does not get cleaned up correctly or even indexed properly, right? And if you're doing proper attack surface management, that's where I would see a lot of this. But also, to John's point, IoT devices, a lot of them are Linux based, right? Like, how hard is it to track these IoT devices and to track and monitor all of these one-off little messenger devices that simply are pumping out data streams to give you, you know, they're being helpful, but at the same time, it's still an interface with the internet.
Yeah.
So
yeah, that's a good point. I didn't really think about like the embedded Linux like scale across the board. I'm sure is just an entire nightmare right now.
Yeah, and let's be real. When was the last time you thought about like, hey, I didn't update my TV last night, right?
Yeah.
You don't think about that.
Right.
You don't think about like, hey, I have a refrigerator that goes to the internet. Should I update that? That's not
What
your
fun.
top priority, right?
Update my washing machine.
Correct.
Right.
Yeah.
So how would you say containers, sandboxes, multi-tenant environments hold up when the foundational kernel layer underneath them breaks?
It's pretty complex, the relationship between containers and the actual underlying infrastructure. In theory, right? Like in gaming theory, if you could somehow interact with the kernel and exploit the kernel, then in theory, you could essentially move over to or break out of that sandbox or container, it would be a highly sophisticated attack. And you would have to understand exactly how containers, like that specific container or technology that you're targeting, works. So I don't know that we'll see a ton of it from this kernel exploit specifically. But I would say that if you see that, then it's probably not your everyday like.
Yeah. Well, let's talk RCE for a second here. GitHub rushed to fix a critical vulnerability in less than 6 hours. This from The Verge. Wiz Research disclosed a critical GitHub vulnerability, CVE 2026-3854, that let any authenticated user trigger remote code execution on backend infrastructure with a single Git push. The flaw stemmed from inadequate sanitization of user-supplied push option values being injected into internal protocol headers, giving attackers access to shared storage nodes that housed millions of public and private repositories. GitHub identified the root cause and deployed a fix inside roughly 75 minutes, with the broader 6-hour window covering full validation, deployment, and a forensic review that found no evidence of exploitation. So if a vendor can deploy a fix in under 2 hours, what does that say about the gap between vendor patch speed and customer remediation speed in more like everyday enterprise environments?
I will just start by kind of tying back to the conversation we're having about the Linux vulnerability, right? Talking about these multi-tenant environments, right? If you think about it, GitHub is a multi-tenant environment where anything that GitHub does on their own platform, it affects basically everyone, right? I mean, it depends. I know there's caveats, sure. But it affects everyone. So the 2 hours window, it's highly critical. You may say it's fast, but you also can say because of the massiveness, or because of how big it is, it's maybe too slow, or it was just in time before something bad happened, right? So I think it speaks on what type of service you are delivering, right? Yes, I'm not worried about updating the Linux kernel for my TV because who uses it? Only myself. The probability of it being hit by an attacker, it's not zero.
It's not
but
zero.
It's slim.
Yeah.
Correct. It will never be zero, but it's slim versus an attacker targeting GitHub to access, you mentioned 70, it was, sorry,
70.
how many millions?
It just said millions. Yeah, I didn't
Millions.
see exactly how many.
Yeah, versus just trying to target millions of things. I think that's the importance of why it was that fast, right? Because of the impact. I think that also gets into the play, right? Like organizations tend to not patch that fast because the relevance tends to be lower based on risk factors they decided, right? It doesn't mean it's a bad practice necessarily. I think it's a bad practice that you don't patch frequently.
Yeah.
But I think the point is, well, you are not impacting millions of repositories that impacts millions of devices, of softwares, of applications across literally the entire world, right? I think that's where that quickness resides. And I'd say 2 hours maybe a bit too long, right? Considering the impact of it.
We've seen you can do a lot in 2 hours now. Yeah.
Yeah, and we've said before about how business decisions are kind of something that are sometimes transparent to some of us in the more technical roles. I think this is a case where on Microsoft and GitHub's part, the business decision side of this was we need to fix this right now because of the large scale impact here, and I think whether or not they could have done it faster is irrelevant. They did it as fast as they probably could, and I think that's commendable in this case because this is. If you look at pick another random company that's got patch advisories out that is having to make the same kind of decisions, I think it's rare to see fixes like this happen this fast for something that's such large scale reaching outside of that organization. And I think that maybe that played a part here. If this was something that would have affected would not have affected customer data. In this case, maybe that they would have been a little more slow to patch, essentially.
Yeah.
But
I think GitHub probably realizes how juicy of a target it is too. Absolutely. And so that preparedness would come into play where a lot of other organizations that get attacked like this don't live on that edge that GitHub lives on.
Correct. Yeah. And I'm curious about how I'm not sure if it really dove into it, not necessarily in the article, but in the in Wiz's write-up, but like I am curious about their process for how they discovered it. I know they said it was AI assisted, but that's my first I want to know more button being hit here is what was their process for discovery here? Like, were they just like constantly scanning something, and then as soon as some change occurred, it just got piped in? Like those, those are the brain tickling questions that I have about this particular scenarios. If in this case a third party organization was performing this type of live vulnerability research in essence, who else is doing that? Who untrustworthy maybe is also doing
Yeah.
Go ahead, Dylan.
This is an interesting one. I think GitHub certainly went for their speed run, right?
Mm-hmm.
Yeah.
But I think the framing of it too is really important, right? Like we talk about the 2-hour window and then the 6-hour window. And I think what's realistic for most companies is really that 6-hour window, right? It's easy. It grabs attention on the headlines. GitHub remediated this in 75 minutes or something like that was like the final summary. But it's important to really understand what's happening in that 75-minute window. And that's identification and potential patch remediation. And then you see that 6-hour, we'll call it window, right? Where this still exists. It hasn't actually been deployed yet. And then they go through that normal business process of actually testing and then pushing out patches and remediations. And then they do follow-on remediation testing. And I think we're kind of doing large scale companies or even the smaller businesses a disservice by being like, GitHub can do it 2 hours.
Right.
Well, not really. If you dive into it, yes, they identified it. They proved proof of concept. They figured it out. They did build a patch within that 75-minute, but they're following the same processes as everyone else. Right. So yes, they're fast, but they also took the time to be accurate, I think is the most important takeaway here.
Yeah. It wasn't just patch it quick and hope. It was
correct. And I think both John and Dylan touched on a very important part, right? Like the business kind of awareness of it. Like if you think about the other businesses, let's think about one of my favorite ones just because of how complex they are, banks, right? Something like GitHub and SaaS providers and technology providers, they rely a lot on the availability of their service. That's their business, right?
Yeah.
For the service, for the information to be available at all times, basically. Something like a bank, yes, the availability is important, but your money being safe is more important from my perspective, right? I wouldn't mind my bank pulling the plug for a couple of hours and being like, hey, we want to do this the right way. So sorry if you can't PayPal or Venmo your friend $50, but I really need to patch this thing, right? Versus GitHub, where I need to pull the code. Right now, I think how many of us in the backend are running things related to GitHub, right? Like I think, on our second monitor, even though we are in this podcast recording right now. I think that's the interesting part, like the business awareness and how fast you can decide. I bet a bank has more audit things to do, right? Like there has been a chain of command, there has been a lot of approvals, there has been very intricate processes that align with different policies. I know several countries need to align to Sarbanes-Oxley, something like that. Not everyone. PCI. I don't think GitHub has to deal with that. They still have to comply with several stuff, but not with that level of intricacy and paper-heavy tasks, right?
Right.
Yep. All right. Well, let's talk about this week from the Hacker News. We have poisoned RubyGems and Go modules exploit CI pipelines for credential theft. A threat actor operating under the GitHub account Bufferzone Corp has run a sleeper package campaign across both RubyGems and the Go module ecosystem, publishing benign-looking utilities that impersonated libraries like Active Support Logger, Devise JWT, Go Retriable HTTP, gRPC Client, and Config Loader. The packages built trust over time before being updated to add malicious payloads. RubyGems harvesting environment variables, SSH keys, AWS credentials, etc., while Go modules modified GitHub and poisoned Go proxy, weakened checksum protections, and tampered with Go.sum. The packages have since been yanked or blocked, but the playbook is still out there. Patient publication, delayed weaponization, registry-aware tradecraft. So how does that sleeper package model change what malicious package detection needs to look like, given any single point scan would miss it.
It's tough, right? I wrote an article before about the Axios supply chain attack. And I said, I think we're going to see more of this like moving forward, right? As people are now with AI, enablement able to push out packages that look legitimate. And, even now too, as we move into this index of how fast can I be to push something, or how fast can I get something down, pull it into my ecosystem and make sure we're using the cutting edge. In that, we're kind of short stacking everyone's reading and knowledge of what they're actually installing. So again, I think package review and monitoring is going to end up needing to be a continuous effort. Package trust can no longer be treated as static or just blindly inherited. Every dependency is a relationship, and that can change after you adopt that technology.
Yeah. I think from like this in particular kind of reminds me of, you might have to correct me, I think it was the executils backdoor that was kind of the same timeline of like, you had a developer that everybody had trusted for, I think it was like a number of years maybe. And then all of a sudden, like, spooky, suspicious backdoor gets pushed. Now, I don't know, like the code maintainers for any of these packages, I don't know necessarily what their trust model is for pushing code into these repos. But I think this kind of harps back to like two-person integrity type things. I think if you like mandate in your repos some sort of a review process from what you would consider trusted people, that minimizes the impact or minimizes the chances. But on the package maintainer side, that goes only so far, right? Especially if you end up with a hostile takeover type situation. But then on flip side, or on the other side of the equation, on developers like us that depend on some of these packages, it comes down to scrutiny, right? If you are, I don't think I would be just blindly installing packages. If this was something, I also, throw it out here, I also don't use Ruby, and I think nobody should. And that's just, maybe this is just like playing into some of that bias a little bit.
Spicy takes.
Yeah, like maybe that's just playing into like some of my biases here. But because this is not. I mean, let's just be honest. This isn't strictly a Ruby problem. This is strictly a Go problem. We've seen this in Python. We've seen this across every language. I'm just picking on this one because of my biases.
Honestly, from what I'm seeing is that the attack model hasn't changed that much. It's another sleeper with a trusted account attack, a supply chain attack. It didn't change the rules that much, right? I like these types of attack because all of the intricacies behind it, right? When we look at the details, I was researching this in particular because I find it really interesting. The account was created at least for 7 months. It was established. 7 months providing legit Ruby packages, so people started to trust it, right? Like, and it's Dylan mentioned, right? Like, it's tough. How much time do an account or an user has to exist for you to consider it to be trustworthy? I don't know. Sometimes I don't trust myself, It's really, really hard to determine that. The other thing is, so after 7 months, it hits and it's kind of gone, right? Did what it was supposed to do. It worked, right? This is why in the previous one I was saying like 2 hours is maybe not that fast because of this type of situations, right? Like you have specific models deployed across your entire app because you work on Ruby, as John said, for some reason. So how do you fix that, right? Like 2 hours is too long because you already have data theft in that package.
Yeah.
And the other thing I was pivoting some data. Buffer zone, the name is very particular. There's at least 2 companies with renowned name that have buffer zone in it. One of the companies is a cybersecurity company. So, right, when you Google like buffer zone, what is going on, and the first thing you see is a cybersecurity company, you're like, okay, maybe I can trust this, right?
Yeah.
Correct. I think those are different, like
emails that look like they're from your bank, but one letter's off or something. It's trying to hide.
The A is in Cyrillic, right?
Right. Yeah. Why's that letter upside down? What is it about this about a developer pipeline that makes it such a juicy target compared to like a production infrastructure?
Inherited trust, inherited access, inherited persistence. No shame on the developers out there, but developer pipelines contain a lot of times like hard-baked credentials because you don't want to build out full app functionality to test one thing. It contains source code, first of all. And then again, trust access to other applications and APIs, within this dev environment. And then again, I think that just the nature of spinning up temporary boxes for development, again, you're accidentally creating that internet-facing shadow IT sometimes and forgetting about it.
Yeah.
And it's a highly juicy, like lucrative box if you can land one.
Yeah. And the trust factor I think is a big one too, where, a lot of times in some organizations, your developer pipelines or your developer ecosystem in general maybe has too much trust across the organization. Again, going back to like code reviews, 2-person integrity, stuff like that. If you're a small organization, maybe like don't see a need for having mandatory code reviews on your approaches and stuff like that. One attacker or one developer getting getting targeted by one of these packages, or even just accidentally or whichever, getting compromised, now opens up the rest of the organization to take over. And who knows where it goes from there, right? So in this case, it was just, stealing credentials. Maybe the next follow-on is using those credentials to gain access and then become a ransomware campaign.
And or to run local privilege escalation vulnerabilities, as we saw in the beginning, right?
Yeah.
Uh-huh.
And the other thing is like someone with real malicious intent, right? Like I will target. It's a supply chain attack within a supply chain attack, right? Think about companies software developer companies that provide services to other companies. How much access do they have to those other companies, to their GitHub accounts? So it's kind of a, like a wormification of the supply chain attack where you just keep spreading it everywhere. Because again, one of the goals was credential theft, right? It's as simple as that. I'm just harvesting for credentials.
Yeah. Well, let's move on and talk about some rats. Quick rats, that is. Daemon Tools supply chain compromise. That's a transition. Very skilled transition. Kaspersky's global research and analysis team uncovered a supply chain compromise of Daemon Tools in which the official vendor website distributed a trojanized installer in versions 12.5.0.2421 through .2434, and since fixed in 2445. The installer drops a backdoor capable of deploying QuickRat, an implant that supports multiple C2 protocols and injects payloads into legitimate processes like notepad.exe and conhost.exe to blend into normal endpoint activity. Kaspersky observed thousands of infection attempts since April 8th, with about 10% landing on organizational systems and around a dozen confirmed compromises in government, scientific, manufacturing, and retail sectors across Russia, Belarus, and Thailand, with artifacts pointing to a Chinese-speaking threat actor. This is from Security Week as well. When an attacker delivers an implant inside a signed trusted vendor installer, which detection layers are actually going to still apply?
I think it's going to be your behavioral analysis, your heuristics, right? Just because I installed something from a trust. First of all, like hot take here, right? Kaspersky being the one to come out and say we uncovered a supply chain compromise is hilarious to me. A big old Spider-Man meme on here for this one.
Yeah.
And then of course, it being Daemon Tools, like it's funny to me that's even still in use, just because of what I recall using Daemon Tools for and like Windows XP timeframe. Like that's when I remember this being like a popular set of software, and I'm sure it still has its use cases. I just didn't know it still existed. So that's already like news to me, was that Daemon Tools was still around. But back to your question, no, I think this comes back to like, just because something is coming from what has the proper signatures and all of those things that go into package signing and trust. If I install it and it immediately, this piece of software just starts beaconing out. I mean, that's happened before with legitimate packages, right? Where a company has just decided, you know what, we're not making enough money on sales. Let's start harvesting customer data and add that to our revenue stream. I think this still like we still need to, as as individual consumers, we still need to be a little more mindful of what is entering and exiting our network, right?
I think for this attack, one of the hardest parts is, yes, granted, there was companies, governments that were affected, but the actual user targeting of this is normal users like us, right? So what
Yeah.
layers of security do we have? Like, yes, I have certain things to secure my house because I don't want to access bad content, but I don't have a $100,000 firewall just scanning for all of the traffic, right? Like,
Yeah.
who? Maybe someone has.
Bishop
I
Box
have some
does not
friends.
let you expense that.
Not yet, not yet, not yet. Yeah, and I think that's the tricky part where this attack uses Quick is very particular, right? It was built in security and speed within the UDP protocol. So it's like a super secure, fast UDP. How do you detect that, right? And based on HTTP3, which is kind of new, right? So even modern security layers at corporations, they don't scan for that kind of stuff, right? And I've seen really a little amount of companies actually scanning for the UDP traffic and seeing what's legitimate or not, right? They don't have that in place. It's not common. And I think that's where this really shines, right? Like even actors are modernizing, using new protocols, using AI, right? Like it's and it's not a new thing, right? They are using new technologies because everyone uses using new technologies.
Sure.
Yeah, I almost feel like it feels like it's a wasted rat because like
Yeah.
I'm impressed with that part of it, right? Like you said, Quick is not something that's heavily scrutinized. UDP in general, I feel like doesn't get scrutinized as often just because of the nature of it. Seeing something like this, like again, putting my bad guy attacker helmet back on and like looking at it from that perspective, like I would hate for my tool to get burned on something as low scale as the daemon tools install. Now, maybe this is part of a bigger campaign that we just don't have all the details on, right?
Yeah.
Like you mentioned that this was seen in certain government entities and whatnot. Maybe that's the entire point, is they knew that this was a piece of software that was explicitly being installed and utilized in those organizations, and that was the target, not necessarily like we, the consumers, were the byproduct of this attack.
Yep.
So yeah.
Yeah, it is kind of interesting, right? To John's point, when I was reading this article, first and foremost, we've talked about it in the past. Crime is a business, right?
Mhm.
And they're trying to minimize their own risk of detection before they can derive any sort of like meaningful intelligence or profit, right? Attackers' tools, techniques, and procedures are expensive. They cost time to develop and money. So it's interesting to see attackers kind of treating their tools like this, like making a ton of noise. And to John's point,
Right.
yeah, it kind of feels like a waste of a rat. Like what are we doing?
Yeah. Let's talk about another big story, the big story, I guess. Cyberattack hitting Canvas system used by thousands of schools during finals week in a lot of them. Talk about timing. Canvas, the learning management platform used by thousands of schools and universities worldwide, went offline during an apparent cyber attack just as many students were preparing for finals. Threat analysts say the group Shiny Hunters claimed responsibility and threatened to leak data tied to nearly 9,000 schools. I think I read it was like, I don't remember, millions of students, including private messages, identification, other kinds of records. The outage caused immediate disruption across higher ed, with students losing access to assignments, lecture notes, grades, study materials, and some universities delaying exams and scrambling for workarounds. What makes this notable isn't just that it's this breach, but it's how dependent institutions have become on centralized software platforms that have turned from what we think of as tools or software into an operational infrastructure. So when something like this goes down, academics goes down, essentially. And as someone who in the last 5 years went back, like during the pandemic, went back to school, did a lot of online learning, I can attest to that. The classroom is Canvas. The gradebook is Canvas. So how do we think about this as in terms of what used to be software and now it essentially is an infrastructure attack?
Yeah, no, I think that's exactly the right way to look at it. If I'm, going to soapbox here for a minute, I fully look at our entire education pipeline as critical infrastructure. Just from like a person, what's important to John, right?
Yeah.
And I think with that, it needs to have a little more a little more scrutiny in place, because like you said, right, Canvas goes down, everything really goes down, right? I mean, even beyond the, I know the focus is on colleges with the article, but like, you know, my kids' schools use Canvas, right? Like it's affecting, you know, primary schools now. And so firstly, right, with it being, you know, with that mindset of it's a critical infrastructure, I think there needs to be backups in place. There needs to be a second plan of what happens when this goes down. How do we continue offering our, you know, our service in order to, you know, maintain uptime, right? Depending on one singular product like this, I think creates unnecessary risk.
I believe the sad part of this is because many years ago, I used to work for a university, actually. I was in charge of the infrastructure, and I wanted to implement a lot of things cybersecurity related. But the problem is that schools do not allocate that much budget as other type of organizations do. I guess, my guess is because of the type of regulations that are almost non-existent for schools. When you think about it, right, a school, it has access to medical records of the students, to photo of the students, to private information of the students, to credit card information. It's actually a lot of information that they have, right? And they don't have to be compliant with any of that, right? Like HIPAA, they don't have to be compliant with HIPAA, but they have to be compliant with, I think it's FERPA, the other one. That is like the federal. There is for those who have minors. I know they have the children protection, the COPA. I don't know if that's the pronunciation of it, but and they have that, but it's not heavily regulated. As in, hey, if you don't comply with this, you are under investigation or something, right? So without them needing to comply to something that makes it have an actual like reason to allocate budget for it, it will be really hard, right? Because yes, it's infrastructure. It's infrastructure that they are implementing inside and that is unregulated. And we go back to all of the conversations of the previous topics of today. Right? Unpatched, play attack, like what else do you want? It's the perfect scenario and target for someone as the Shiny Hunter group, right? And their partners, right? Like there is a lot of information that you can extract from a school. And we have seen also that in the past, right? Like students, it's not uncommon that no famous hackers working in cybersecurity companies tested their infrastructure, the cybersecurity of the infrastructure at their schools. Why? Because they could. No one was stopping them, right? So not surprised. It's sad to see that. And yeah, there needs to be more alignment from schools. And this is a worldwide problem, right? Like where I live, it's a problem as well. It's not just the US. It's a worldwide issue.
Yeah, and I think like you said, right? Like it's not it's not the school's fault that they don't have enough money, right? Like it's not like they can control that their source of income, right? That's a policymaker kind of problem. And so it's frustrating because it's like we consider and say like, oh, they need to beef up their security, but it's like, okay, well they also need to feed the kids, right? For lunch. They have all of these needs they have to take care of. So it's understandable from a funding perspective why this gets overlooked. It's a frustrating reality of the situation, right? And the timing of it, and like with it being, you know, this is finals week for a lot of schools. I think that just speaks to like I never want to like tell an attacker job, but in this case, like they picked the right time, because if their goal is to extract funds to get somebody to pay them, like think of it as like a hostage situation, right? Like it's the same concept. You're going to make sure you want to take, if your intent is to get somebody to pay you to give back something, you're going to do it at the most opportune time. And this is the highest value time.
Yeah. You don't rob the store after the Garda truck picks up the weekly funds.
Exactly.
Right.
Sick man, we have $5 in the register. Take it.
Yeah. Right, just for the love of the game.
Felons.
Yeah, I think the interesting thing here too is when we talk about education, like we've talked about how diverse the ecosystems are depending on the level of education too, and we've kind of just skimmed right over it. Obviously, like Canvas is across elementary schools, high schools, and even some colleges like implementing this technology who have drastically different budgets and different understandings of the cybersecurity ecosystem. And it's crazy that none of them are communicating about a standard for this type of infrastructure, right? So obviously you're going to get less security likely out of the elementary schools or the high schools that are running off a smaller like county, state, or federal budget, depending on whatever. So again, you add a lot of complexity to this, and it systemically creates this perfect storm for attackers to take advantage of
Yeah.
and hide in the confusion.
That's what I was going to say about the budget is like when you think about your average primary school and how they survive off of selling flavored popcorn and like these little fundraisers to barely scrape by everywhere. So an attacker knows they don't have money for proper any kind of, they don't have any pull with that.
Yeah. And on the other side, and that's why I mentioned the compliance part. I know for this attack, Harvard, Princeton, Columbia, so universities that I know get a lot of money, right? But because they are not that heavily regulated, got attacked through this. It was a widespread attack. So even those, right? Like no one was safe just because it's a combination. Either you didn't have budget or you didn't have rules or policies to apply. So both are perfect, right? Like
right. Yeah, the policy thing or the lack of teeth, right, to some of those regulations. I think that's a good point you bring up. Is like the regulations may exist, but like if there's no like repercussions or if there's no like really big repercussions, right? Like we said before, how like if the fine for not protecting my data is less than the the cost or whatever, it's just the cost of doing business at that point. And it's unfortunate that that's the truth, but it just is.
Yeah.
I'm going to end up on a whole soapbox about government stuff and whatnot.
I always say in the city, if you can afford the ticket, then that's just how much it costs to park there that day.
Yeah, exactly.
Exactly it.
All right, let's talk finally about CISA a little bit. We mentioned 2 hours might be too long, but according to Reuters, acting CISA chief Nick Anderson and U.S. National Cyber Director Sean Cairncross are weighing a proposal to cut the deadline for federal agencies to remediate KEVs from roughly 2 to 3 weeks down to 3 days. The reported motivation is concern that AI-accelerated exploitation is compressing the window between disclosure and weaponization, though Reuters notes that for some environments like OT, legacy systems, embedded, 3 days could be simply impossible. No final decision has been made, but federal deadlines historically set the de facto bar for state, local, and commercial sectors through cyber insurance, regulatory expectations, and procurement language. So if exploitation timelines are compressing, which we've seen this week and every other week, they are. What does that mean for offensive operators and the windows that they have to work in?
It's an interesting concept, and often there's a trade-off, right? Speed versus accuracy over shortened testing and shortened implementation windows, but also government process. If anyone has been around it, can attest that speed does not typically go hand in hand with that term.
Correct.
But some of that works in threat detection and modeling. Threats are becoming more and more complex. Attacks can be chained easier and impact multiple versions of software. So, first you have to create a detection for it if there's no public POC. Then figure out where in the world that tech is deployed across your attack surface. Then you have to remediate it, test it. And we're talking about taking, again, GitHub did it in 6 hours. And everyone went, wow, that's the gold standard, right? 6 hours is crazy. And I just don't think you're going to see that across the industry. I mean, GitHub is kind of the perfect storm, right? It's a very modular, centralized, everything is ubiquitous throughout. The structure's the same. So it's kind of like, hey, we found this bug crawling around in the doctor's office. And it's like, well, you should, because the doctor's office is super clean. Like it should stand out immediately. Whereas everyone else's infrastructure is a lot more messy, right? It's not this nice, neat bundle of applications that all work together.
Yeah, I think you brought up a good point with speed versus accuracy, right? When you have like a longer patch window like that, I think that's when you see some of the more surgical exploitation attempts occur because people have had, or attackers rather, have had time to test it on a lab or figure out what exactly they need for, if it's an exploit that needs tweaking on a target to target basis, right? They've had the time to do so. I also agree that it is kind of a little, I won't say unrealistic, but it is a little bit of a stretch to me to expect 3 days to be respected in government entities, just because kind of going back to what I just said before, like what's the negative if I miss the deadline, if I'm a government entity and I miss the deadline, what happens? I miss the deadline and I still do it as fast as I possibly could. But like, if there's, maybe there's just a piece of this that I'm missing. But like, if there's nothing to enforce that from like CISA standpoint, and I don't believe that they have any authority, then at this point, it's just a suggestion.
Yeah.
Yeah. And I know I was on the extreme when I say 2 hours is probably a little time, but I think this is my point, right? And why this is important. Yes, it's 3 days to patch. But the problem is not 3 days to patch, is that at least for 180 or 90 days before that, the vulnerability already existed and someone discovered it, right? And how many months before that, or at the same time, did an attacker weaponize that already and is attacking, right? So the 3 day is, well, you're comparing the 3 day versus the 180 days that it was really discovered or known by the vendor, right? So that's why 3 days becomes, you need to patch it really fast. So 2 hours is like, really, patch it after 1 minute, right? It's really important because it was discovered for so long already that it's been attacked in the wild. How many of those vulnerabilities we don't really know? So for those that are known, that are released, that are critical, patch them right away. I know it's hard. I'm not saying like, yeah, just skip any due diligence and process. And I'm not saying that, but I think it doesn't make it less important for that vulnerability being critical that you need to patch it right away.
Right. Absolutely.
I think what concerns me about this is just the blanket language of like, you have 3 days to patch vulnerabilities, right? And it kind of leads me to thinking, I can't help but reflect on the last half an hour that we've been talking about people rushing into patches without exploring the code, supply chain attacks. And it's, are we creating this own ecosystem of pressure to where we're forcing people to blindly inherit trust from these external vendors? And are we then going to perpetuate this cycle of just install the next best thing so that we're compliant within 3 days? Oh my God, we got supply chain attacked again.
Yeah. That's a great point. Yeah, I think that's a really good takeaway. Is what are we missing by shortening our deadlines? Because I mean, like, how many, look back at like previous jobs I've had, like, how many times has somebody said you have this unrealistic deadline, and like it's my priority suddenly changed from do it right to do it fast. And I think you're right. I think that you're gonna you're definitely introducing a new type of risk to the process.
Well, if there's a common thread, as always, it seems that window is shrinking. Big takeaway this week, even the government is talking about speeding things up. So maybe you should think about that as an organization as well. If this episode helped you think about the week a little differently, share it with someone on your team. Initial Access is a Bishop Fox production. Until next week, stay safe. And gentlemen, thanks for joining.
You take care.
Yeah, thanks for having us.